In this video, we're going to use the ideas of vectors to find the distance between 2 points in space. So these are going to be 2 points kind of floating in three-dimensional space somewhere, and we want to see how far apart they are. So the distance we're going to use, we can think of this as the length of the vector. Now we know that vectors don't actually have, we can't really use distance for vectors because vectors, distance is a scalar quantity. Vectors are not, they don't have distances. So we're just going to kind of figure the length of this vector. Okay, so we've got two ways that we can do this, two methods. The first is to find the distance, use the distance formula, and the second method is to find the magnitude of the vector. Now you're going to find that as we do these two things are very, very closely related. They're very similar to each other. But let's start with the distance formula. So we're going to take 2 points. We've got point A, which is going to be in the three-dimensional space of 1, 3, 4, and point B, 4, 2, 7. So now again, remember, this is these points are not fixed anywhere. They're just fixed that you have to go 1 away from the origin, 3 on your y, and 4 back on your up on your z. So you can move those around anywhere, just as long as we know that that they're going to change that space in that same units for each x, y, and z. All right, so our distance formula. Our distance formula is just like we've done in the past when you've done distance formulas in geometry or algebra, and this is going to equal the distance of x from one x to the next, from one y to the next, from one z to the next, squared, and then taking the square root of this. This is actually an offshoot of the Pythagorean theorem, so so that might also help you wrap your head around this. If you only are in 2 dimensions, you're not going to include those z values, but this is very similar to that Pythagorean theorem. So let's plug in our values. Our second point is B, our first point is A, so we're just going to plug in 4 minus 1 squared, right? Just taking 4 and subtracting the 1, taking A and subtracting it from B. So that's going to be plus 2 minus 3 squared plus 7 minus 4 squared. Do some basic algebra and we get 3 squared plus negative 1 squared plus 3 squared. So we have the root of 9 plus 1 plus 9, and overall we have the square root of 19. That's our distance. Now let's look at the magnitude of a vector. Again, this you're going to see where this is very similar to the distance formula. But our magnitude, we're going to look at negative OA plus OB. Now this assumes that we have these 2 points, A and B, situated near the origin or coming away from the origin. So OA is going to be going from the origin to point A. We're going to create a vector that goes 1 space positive on our x, 3 spaces positive on our y, 4 spaces positive on our z, and same with our B. So we're going from the origin out. But we know that we have to have our vectors following a path. They have to go heel to toe. So we can't go OA to OB and then finding the vector AB. We have to reverse OA. And if you're not familiar with this, you may want to go back and look at the position vectors video where we talk about this a little bit more. So we're going to reverse our vector OA, and that's the same thing as subtracting OA from OB, just using our basic properties there. And we're going to then put in the values of the points, 4, 2, and 7, minus 1, 3, 4, and we're going to get the result of 3, negative 1, 3. And if we write it in unit form, that's the same as 3i minus 1j plus 3k. You may also already notice that this is the same values that we had in our distance formula. So when we find the magnitude, all we're doing is we are finding the magnitude of our I, j, and k, or our x, y, and z, and we'll plug in those values, 3 squared plus negative 1 squared plus 3 squared, and that's going to equal, just like before, the square root of 19. So those are two ways that you can quickly find the length or the distance of a vector. I should say a distance between 2 points in space, or the length of a vector, because we did kind of create a vector for the second example there. So I hope this helps, and we'll see you or talk to you in the next video.